Hi, I'm going to tell you a story of a friend of mine who took his vehicle. It was a 2011 Ford F-150, and he took his vehicle into a shop to have it diagnosed because number one, the service engine soon light was blinking. Number two, the vehicle was running rough and making a noise. So therefore, he took his vehicle in, and the technician actually diagnosed the vehicle and indicated that there was a fault with number 3 cylinder misfiring, and he recommended the ignition coil along with the fuel injector needed to be replaced, as well as he recommended all the ignition coils for the simple fact that it needed a maintenance to be performed to prevent the vehicle from misfiring in the future's tense, which could have been 3 or 4 months down the road. So to prevent that from happening, he recommended that all 8 ignition coils needed to be replaced along with a major tune-up. Okay, so after doing the repairs, by the end of the day, the vehicle still had the same symptoms. Number one, the service engine light was blinking. Number two, the code for the number 3 cylinder misfire was still present. So therefore, it didn't really fix the problem at that particular time. Well, that was at the end of the day, and a friend of mine went to go pick his vehicle up because he needed it for the next day. That was his only mode for transportation. So he gave me a call and asked me to look at it for him, so I did. I saw the vehicle as it came into me, and I saw that number one, the service engine light was blinking. Number two, I did perform a scan tool test to determine that there was a problem with number 3 cylinder still. So as I did that, I did a power balance test first. We're going to cover the main areas, which is a power balance test, the compression test, cylinder leak down test, and finally a vacuum test. For the shortness of the video, I like to incorporate both the cylinder power balance test and the vacuum test at the same time, and I'll explain why in a little bit here. So when you're performing a cylinder power balance test, when you're doing this test, number one, you got to program the scan tool, which I have right here. This is a scan tool, and you're going to program this guy right here to cancel the cylinders out. And the computer, what that will do, will disable the fuel systems on each particular cylinder one by one in a span of 5 milliseconds. When it does that, what should be normal is each cylinder, as it goes through a 5 millisecond process, cylinders RPM should drop and the idle should shake and the vehicle should misfire. That means it's producing a power stroke. That is normal. When you get an abnormal reading, what happens in this instance is there is no drop in RPM at all. So the cylinder stays the same idle quality, which is low, which is not good. That's when you determine there's a problem within that cylinder that requires more in-depth testing, which is going to be the next one, which is the compression test. So what's the purpose of a compression test? Well, the compression test is to determine a cylinder that failed the power balance test, that is not producing a power stroke, okay? So how do we do a compression test? Number one, we have to disable the ignition because we do not want that engine to run. Number two, we're going to open up that throttle after we take the spark plug out, and then we're going to go ahead and crank that engine 5 engine revolutions. After 5 engine revolutions, we're going to see a couple of things on our gauge, and this is a compression tester right here. This is a compression tester that we use here in the field. The reading in here, if it's a good compression, it should be 100% and above. A bad reading, of course, is going to be below 100 psi, which would indicate a problem. After we've indicated that we have a low compression, which wasn't the case with my friend's vehicle, the next thing we're going to perform is a cylinder leak down test. And this right here is a cylinder leak down tester right here. The way we do this test is we're going to put that piston at top dead center with both valves closed, okay? We're going to introduce shop air pressure, and we got a regulator here that we're going to regulate this left gauge to your side to 100%. After we've done that, of course, the spark plugs are already out. We're going to install an adapter and hook up our tester onto the adapter. A good normal reading is going to be 5% or below. If it's 20% or 30% or above, that means that cylinder is dead. If it's above 30%, now we're going to look for and listen for air escaping out of the intake throttle body unit. That would indicate something wrong with the intake valve. We're going to also listen for air escaping out of the exhaust system, and if we have that happening, then we know we have an exhaust valve that's stuck open. The next thing we'd want to check for is, if we pull the dipstick tube out, the same dipstick tube that you use to check your oil, and we hear air escaping out of it, we have a problem with the piston rings. Okay, so that is the rundown on the cylinder leak down test. The next test that we want to perform, and this is the one that I mentioned earlier, I like to perform with a cylinder power balance test, is our vacuum gauge. A good engine should have at least between, manufacturer says, 15 to 21 inches of vacuum steady. For engine mechanical diagnostics, I need to see it at 18. If it's at 18, it's good. Well, when I hooked up the vacuum gauge to the customer's car, this needle was fluctuating between 14 and 18, which is not good. Okay, that indicates a problem with the valve train. So basically, the customer, my friend of mine who took the vehicle in, noticed that the vehicle was running rough. So in retrospect then, all of this that needed to be replaced, that the technician that recommended, did not fix the problem. It needed more in-depth issues. And the issue with this particular vehicle was the camshaft. I'm gonna show you this camshaft here that we replaced. And basically, this is a cam lobe. This is what a normal cam lobe looks like right here. You can see all of them look like the same uniformity. Take a look at this one right there. This was number 3, intake. This is the issue right here. So the problem on this one was a lack of lubrication and lack of maintenance, and it caused the camshaft lobe, another component, to wear inside here on the cam lobe, which caused an engine vibration and concern. So basically, if the technician would have performed, number 1, the cylinder power balance test, number 2, the compression test, number 3, the cylinder leak down test, and a vacuum test, it would have came to determine that all the components that he recommended to be replaced really didn't need to be replaced. It was more an engine mechanical. In this case, it was the camshaft, which was installed in the middle section of it, plus other valve train components. For the sake of the video, I probably won't go into that because that's a little bit more. But in retrospect, when diagnosing the customer's concern, the vehicle was running rough, a cylinder leak down test and a systematic diagnostic approach would have nailed and pinpointed a problem with that one cylinder, indicating an issue with number 1 intake valve. I hope you learned something today from this video on engine comprehensive diagnostics. That's why when you're presented with an estimate at a repair facility, we want to make sure that you're informed and to ask these type of questions, to ask them, are you sure this is what's going to fix my issue? And there is no other engine mechanical issues related to my service engine light blinking continuously. These are some of the questions that you would be informed to ask the service manager, and therefore the service manager in turn would verify that with the technician before you pay for unauthorized needed repairs. Thank you for watching.